Okay, so we're here Wednesday, September 30th, for our introductory chemistry course. And we're here today to talk about conservation of matter and energy, right? Brief introduction to energy, okay? And let's talk about conservation of matter first. And when I talk about conservation of matter, I generally like to introduce it. It's just common sense. Okay, so there's many conservation laws in the physical sciences. And let's ask this question. Literally, what does the word conserve mean? What does that mean? You're a member of a conservation society. What are you trying to do? Come on, somebody answer. What are you trying to do? What does the word conserve mean? You're trying to conserve water. What is it you're trying to do? Nobody's going to answer. Okay.
Your video froze, Ray.
Yeah, what was the question?
Okay, I thought it was like the high school. Okay, so the question is, what does the word conserve mean, or conservation? What does that mean?
Conserve, to save?
Save something?
To save something.
Or like not
to
use
save
all
something.
of it?
All right, so we'll just go with can save. So if you're trying to, if you're a member of some wildlife conservation, you're trying to save wildlife. So here we're saving mass, right? Not so much saving mass, but if you have some, well, we've done physical and chemical changes. So let's talk about some process, be it a physical change or a chemical change, okay? And whatever event occurs, you have the same amount of mass at the end as you had at the beginning. The same amount of mass at the end as you had at the beginning. Okay? So I generally like to say, well, if you have an ice cube, a 10-gram ice cube, if you melt that ice cube, you don't have enough water to fill a swimming pool, right? You have 10 grams of water. You melt a 10-gram ice cube, you get back 10 grams of water. You boil that 10 grams of water, you get 10 grams of steam. Okay? So that's the conservation of matter. Right now, that seems like just common sense. You melt ice cube, you're not going to have enough to fill the swimming pool. But what tells us that that's ridiculous? The law of conservation of mass. Okay? The law of conservation of mass. Okay? And there are many ways to state the conservation of mass. We can just say in any physical or chemical process, in any physical or chemical change, the total amount of matter remains constant. We can just view it like that. Okay, there's many different ways to state it. Now, how do we want to apply it here? And I'm going to give you an assignment, a very simple one. Everybody should get 100% on this. We're interested in, now I just gave an example of a physical change. You melt an ice cube, okay? Or if you crumble a piece of paper, or shred a piece of paper. If you shred 100 grams of paper, sheets of paper, you get back 100 grams of shredded paper. Those are examples of physical changes. But we're interested in chemical changes. So let's take a look at this. Let's grab my calculator here. So suppose we have this reaction here. Now, we haven't actually looked at chemical reactions. That's in a later chapter, but that's okay. We can still look at this now. And I should have had some numbers prepared here, but I don't. So let's suppose that we start out with 46 grams, and I don't have room to write out a word problem here. So let's suppose we start out with 46 grams of this. I'm going to write 46 underneath. 46 grams of this. Okay? And let's see here. And we have 71 grams of this. Right? I'm going to leave the unit off. Right? So 71 grams of this. How many grams of sodium chloride will we end up with? All right? And we generally write X for our unknown. Now, we have a chemical equation on the top. Now, again, we'll talk more in detail about chemical equations later, but this arrow since this is an equation, we can think of it as an equal sign. So down here where we're taking the chemical equation, plugging in the masses and turning it into a little math equation, I'm going to replace that arrow with an equal sign. I'm going to take down the plus sign here. Okay, so there we go. What is that? X equals 117 grams. Is that right? Yes, that's right. Okay, so notice the total mass on this side equals the total mass on this side. Now, we should introduce a couple terms here. Okay, when you have either a physical or chemical change, but this is more commonly employed in chemical changes or chemical reactions. Remember, on Monday, we said a chemical change is identical. It's synonymous with a chemical reaction. Okay, so here we have a chemical equation that represents a chemical reaction. And what you start out with, the chemicals that you start out with are called the reactants. The reactants. All right, and reactants get turned into products. Products. Reactants get turned into products. Okay? So notice here the total mass of the reactants, 46 plus 71, equals the total mass of the products. All right? And NaCl. All right? Any questions there? Any questions? Remember that the products are produced. The products are produced, so they're what you end up with. You can think of the reactants, if you like to bake, as chocolate chips, some flour, some sugar, maybe an egg or two. And the products are the chocolate chip cookies, right? The chocolate chip cookies. Now, I want to point out something here, because this is a mistake that some students make, so please pay attention to this. Do not multiply. This is going to be presented to you as a word problem, right? So if I tell you 46 grams of sodium react with 71 grams of chlorine chlorine gas, do not multiply the 46 times this 2. Do not do that, right? Do not do that. Okay, that 46 already takes into account that factor of 2. We'll learn more about that later in the class. Right now, we're just interested in conservation of mass. Okay, it is in this chapter on matter. Okay, do we have any questions here? Again, my advice to you, this is really easy, but it's amazing how some people manage to screw it up. When you're presented with the word problem,